been a while since I've done one of these chats. And today I want to actually make this a chat. No slides, no nothing like that. I just want to say, first off, happy holidays. The reason this has been so long is a little bit of holidays, a little bit of family stuff, a little bit of traveling, a little bit of vacation. So I just want to start out by saying happy holidays, and that's pretty good right there. So PASS has been over a month now, and right after that I had this idea to write up a reaction to Brent Ozar's keynote, because his discussion of how the cloud affects my career was really interesting. And the key takeaway was we suck at capacity planning. And there's nothing more true than that. There's nobody who believes that we do a terrible job. I do a terrible job at it. I write a query, it doesn't run very fast. I tune it and I go, I can't make this faster. It's got to be, we need more resources. And, you get this, oh no, you don't need real resources. We run out of disk space, all that kind of stuff. But I don't want to talk about that. That aspect of what the cloud does for you is very much true. We suck at capacity planning. It's the reason why we have VMs now. We have this big machine that you share a lot of resources. But in the end, what do we tell people to do, right? We tell people to lock in the resources for SQL Server because sometimes you're going to need them. All that's well beyond what I like to do. I want to talk more about how does the cloud affect your relational database design? Does it make any difference? Do we have to start designing differently? Is normalization a completely foreign concept? And the answer to that is coming up. I've been doing this for 20 years. What I really love about relational programming is that there have been very few breaking changes in the past. That outer join thing Microsoft did back, I think in 2005 maybe, that really hurt, okay? You had to get rid of the star equals and equals star for outer joins. That was some code that had to be changed. But other than that, a lot of the code I wrote back in the 1990s, I've worked at the same company a very long time, but and some of the utilities I wrote 25 years ago I actually still run. But what about, what should it change? Should things be different? Let's talk about that. What I find funny about the capacity planning thing, though, is there was a time when people thought computers are going to be too fast. We're going to have no reason for that kind of power. We didn't have that much data. No one was thinking about storing every click, every movement, every little tiny thing that went on in the world. Now we do, right? No one thought we would have lights. We would talk to our lights. We thought that was just the Jetsons, right? Part of it is that now once we realize you can store data about one event, well, I can store data about 2 events and 3 and 4 and 5. And I can try to capture the behavior so precisely that I end up with a lot of data. And we have all of the books are now online. Every one of those things can be processed and looked at. Sentiment analysis, so many things you can do. When I first got started, even probably 10 years ago, I would never have conceived of the kind of amounts of data that we possibly are going to solve. So I'm trying to save. Think about my watch here, right? This thing is watching me all the time. All the time. It's telling me, what's my heart rate, what's my blood oxygen level. It's capturing that occasionally. I'm one person. There are millions of these watches out there transmitting data back to Apple headquarters, figuring out what it is that's going on. I'm sitting here talking to a camera that's on my phone, that's recording on the phone, that's going to go into the cloud, and I'm going to do some processing using tools and put it back in the cloud. So much data. And putting that locally, on expensive storage or stuff was hard. And finding people that could manage it, finding people that understood that. Boats loads of data. And let's be honest, we mostly don't use that data. We have gigabytes and gigabytes and gigabytes of data that we've stored that we don't use because it wasn't that interesting yet. We're only coming to the time where we have tools to do that. Can you imagine how much data is being stored every second just from the people that are watching this? From the watching of this video, lots of video is being stored. So, what does this matter though? Does this change how we design things? But the cloud to the rescue, right? And I'm not trying to usurp Brent's keynote. Go watch it. I'll put the link in the notes. It's a good and informative keynote talking about these topics. But the cloud is there. It can help us, with all the kind of things that get in the way of progress, get in the way of doing things easily, right? Upgrading. You ever upgraded a machine? We got to build a new machine, got to copy all the data and all that. Someone can do that for us. As a programmer, I've always liked that someone did that for me. Now, note a minute ago I did say relational. I'm going to try to talk about whether your relational database has to change for the cloud. But here's the question. What about other databases? Does everything need to be a relational database? I have talked to some people and I said, what kinds of data would you store in relational versus others? And if you ask someone who builds a SQL engine, they go, you can store everything in a relational engine. And they're right, you can. And there's reasons to and there's reasons not to. I just want to focus today a little bit on the relational databases. Do I need to change those to go to the cloud? So knowing what a relational database engine is kind of a key to knowing whether you need to use some other database. There are purposes and values to all the different kinds of databases that are being built, but not always are they the same values. So let's talk about that for a second. For something to be a relational, there's a lot of characteristics, but the main characteristic we care about is that it supports acid, okay? Not hydrochloric acid, but acid. Every time I want to do an operation, it's atomic. Everything that I want to bundle together as one happens as one, or none of it happens. It's consistent. When I store something in the database, I store the value of one, I know I get the value of one. Something can't go back and change that and turn out with something wrong. My constraints will make sure the data is correct. It's isolated. I've got 1 million users operating at the same time. They're all trying to update the same row. That is coordinated. There's no way for one user to overwrite another user's work in a way that the engine that you don't ask it to. Okay, you can easily ask it to. There's lots of ways. We'll talk in one of my later sessions. We will definitely talk about isolation and what it means. But as long as you specify don't overwrite, it won't. Okay. And if specified, I want to read some data, you specify how you're going to read it and how these relationships go together, how these queryers, how these operators behave with one another is well managed by the engine. And then durable. If I turn the computer off, the data is still there as long as I ask it to be there. There are ways to tell it not to be durable using in-memory tables, for example. But that's really a key. Let's talk through a bit of history. Relational databases are not new. No one came up with this in the 2000s, even the 1990s. It was well before that. Edgar Codd, along with others, formed what we know there was a relational database management system in the early 80s. Back in the mid 80s, Codd put out these 12 rules, actually 13 with a rule that says you have to follow the rules to call yourself relational. But these rules, this vision is not something that they've really even met yet. They're getting closer. Every time a release of SQL Server comes out, I haven't seen 2022 yet, personally, but every time they put out, they get closer to the vision. They also kind of skew from the vision, letting you do things that aren't actually meet the relational requirements, but they're getting closer. So these papers came out while I was still a goofy kid finishing high school. But the things that they suggest, and we'll talk about a few of them in a minute, they are things that are coming to fruition now. Basically, these rules specified that you should have a declarative experience, meaning that I just say, hey, computer, could you store some data for me? And it goes, okay. Could you retrieve some data for me? And here's the criteria. Okay. I don't need to care about where the data is. I just ask, give me the data. And he goes, okay. I don't care how it's stored. I don't care the order of the data. I don't care how you access the data. It's built into the thing that you use rows and columns. I don't need to figure out what's in the database. I can go to a catalog and say, hey, what tables do you have? I mean, that doesn't mean that you can just build a table and call it Fred and know that it's the address table. Someone has to do a good job designing it. But ideally, I don't have to look that up. I don't have to check to see what's in the system. It tells me because the people who built it did it that way. I don't need to go to the disk. If you've ever had to write in your college or just hobby programming, routines to go out to a disk and write data, find the places in the file, write it, save it, lock it. You don't have to do any of that. It just happens, right? I don't have to learn how to stop people from constraining data. If I want to make sure that a value is 0 or 1, I don't have to, when I go right to that file, I don't have to say, make sure it's within 0 and 1. I can put constraints on there that say it can only be 0 or 1, or all the values have to be unique. And does this sound like utopia? It absolutely does sound like utopia. Because it is utopia. One of the reasons I was able to excel as a programmer was that relational databases are not as bit and byte and touch here on the disk intensive as everywhere else. It's not to say it's easy. Okay, it's not easy. It's very hard, actually, mostly because you need to learn how to do it and you need to do it the right way. Okay. So, but I'm really bad at the bits and bytes programming. I wrote my college compiler in VB 1.0. I did not get the best grade. I passed, but I did not get a good grade because the professor was not that impressed. He's not as impressed as me. I was impressed at work. But we set up a database following a set of rules, relational rules, normalization rules. There's plenty of other things we will chat about in coming months, naming standards and structures and doing things the right way. But there's a lot that goes into it. The beauty of it is at this point it just works. What you're doing is storing relational data, typically transactional data, but it could be data you're reporting on. There's all sorts of things you have to learn, but it's not that hard. Remember how I said Brent said we suck at capacity planning? Well, in terms of understanding what the customer wants, we are 10 times worse than that. Because how do you figure out what the customer wants? You have to ask them. That would then entail them telling you and understanding what they're telling you. I actually I have a hobby model of pictures for my Disney and Dollywood pictures, and I change my mind all the time because I think, okay, all I need is just a database of pictures, and then I can randomly pick a picture. I also need to group them together somehow. Oh wait, I also need to add that. Oh wait, I also need to. Oh wait, I need to add this, and one of those oh waits in there typically leads to a complete rebuild because I didn't quite get it. And we know how hard that is in the real world because when you have millions and millions of rows and you have money being made from those millions and millions of rows, it's hard to say, okay, we're going to take this down for a couple of days to do the upgrade. And then you're like, nope, that's not happening. Just find a way to make it happen. And we end up with less than adequate designs. So really understanding what the customer wants is the first step in getting good performance. We have a lot of people out there doing performance tuning for a living. And they do performance tuning for a living because we do a bad job of knowing what the customer wants, bad job of setting up the data for what they want, and then writing the queries. I had that problem in my own life. It's hard to figure it out the first time, and once you're so far down the path, you're stuck. I mean, all the relational model is specifically set up to do is for you to design your model to a certain pattern based on the customer wants, and it goes. But we rarely understand the customer's needs until it's too late. So the customer is always right? But is it? I mean, eventually the customer is always right, but too often the scenario is this. The customer wants to do something, and it's either good or it's dumb. Let's just say it's dumb. Let's go with the dumb case first. The programmer says, no, that's not a good idea. The customer still wants to do the dumb thing. Programmer does what they think, and it's not exactly what the customer wants, so we're in a mess. The customer does this dumb thing, we're in a mess. Sometimes customer wants to do something really good, a really cool thing, and then the programmer does a bad job implementing it. There's so many things that can go wrong. The output's less adequate than using a kitten as a pet. Well, there's my southern thing for the day. You know, it sounds cute. You get a little kitten, meow, with a pack on his back, but then it gets crushed, right? Not cool. The problem we face is that the problems in programming usually do not manifest themselves in a way that you know about it until it's far too late. Till you're way down the path, you sit down and you're writing the code, and the customer starts using it, and they go like, this isn't exactly what I want, but we've already spent $10 million on it, so we're not going to make a change, so we'll make it work. And it just fails spectacularly. So you're assuming there's a point, and let's get to it. Relational databases are relational databases at heart. One of the beautiful things about the cloud is that we're not taking databases in one format and it has to be changed into something else. You are just changing the server it's on. You may be changing how much it gives you, how much it does for you, but at its very heart, there are relational databases in the cloud you can use like relational databases. Relational databases are built to use normalized data. So pretty much the fact is, if you did a good job designing your database to start with, then you did a good job. It's still gonna work. You did a bad job, it's still gonna suck. It may suck less because they have maybe more things that can automatically tune your databases in the cloud as opposed to locally, currently. I mean, things are getting better every single version. I'll be amazed if 2022 of SQL Server doesn't improve that some. But the cloud just makes it better. The vendor's algorithms get better. They can watch your usage without looking at your specific data, but they can watch how you're running queries. They can watch what the plans are doing, and then provide some artificial intelligence. They can even provide human intelligence if they want to. I have no idea what they actually do, but without looking at your data, they could do so many things. Because it's not so much about, if you're doing performance tuning, you don't usually go, well, let's go look at the data, and oh yeah, there's Fred, and there's John, and this is the address table, and this person's in Tennessee and this is Montana. Well, that's going to make it faster. You don't look at that, right? You look at what is the setup. What does it work? And those algorithms really cater first to relational data. When you watch how the optimizer works, it's going to look for things like indexes and joins and one-to-many relationships. It's not looking for these where you've built a many-to-many relationship in two tables and things go sideways. It can see the cardinality of the relationships, can see the constraints you put on there. All that works in the cloud just as well. And this isn't a Microsoft. I don't work for Microsoft. I have been a Microsoft MVP for 17 years. It may not pay me my last year. I've not been doing nearly as many things. But the previous year, I wrote a book, and I wrote part of a book, first chapter, and it was talking about the different flavors of Azure relational database management system offerings. And they have an Azure SQL database which is fully managed. The only thing you have to do in these fully managed circumstances is typically build tables, insert data, write queries. And the more you do that relationally, the better. Okay, it's just the same thing you do locally. Same thing as developers do locally. but without some of the necessary tuning. I mean, you can still add indexes, you can still do those kind of things, but it's also done for you somewhat. Managed instances, just like our on-prem stuff, but with more managed. It does more for you. It optimizes some of your code for you. It takes away disks and all the complications. And then you can do slightly managed, which is basically just infrastructure as a service. Here's a server, and they'll do some things for you. The beauty of the first two I mentioned are they're greenfield. You never have to upgrade. They upgrade for you. You know, every time I want to do an upgrade of a server, they always want to build a new server and copy the data. They don't do that. You're on version 15.1. Tomorrow you may be on 15.2. They don't do any backwards compatibility things. They don't take away a join type. Oh, cross apply doesn't work anymore. Nope. They would add something. They may take it away someday. There's some deprecated features in the engine, but they're deprecated. They're not being removed. And from what I understand, they have no plans to do any removing for a long time. The good part is all of these things have basically the same engine. There's also Oracle, others, Progress. I can only think of Oracle right now, but there's all these have the same kind of things. You know, there's a cloud version, there's a local version. It just works. Your code, only thing that changes is addressing. I mean, when you're on a local platform, you have a lot more leeway. Like in Azure SQL database, I really only have one database. I'm not have that kind of, I can just join over to another database really simply. It's more complicated than that. But it's something that you should be doing already. You know, you should not be building one database, one application equals 50 databases that you have to join across. And I mean, you may replicate data, moving data from one database to another to use. That's different than accessing the data in multiple places in the same database. All right, so you have the tools to do what you have been doing as a developer without a lot of change, except to the management. But as a programmer, do I care? All I know is I want to be able to write some data, read some data, modify some data, delete some data, and I'm good. That's what I'm after. So the answer is really no. Your databases don't have to change that much. It largely stays the same. Some of the esoteric features may not work. This is even true if you're using Linux SQL. Like file tables may not work if you're on one of the cloud platforms or even using SQL Linux. There's some things there. One of the features I use heavily in my hobby database is file tables, but we don't really use them in production work. Overall, this works thanks to the vision of COD 30 some years ago. Okay, that's a long time in computing. We can just sit down, write this simple question. Have I had any sales today? You know, a little bit more structured than that. And the computer figures out how to do it. The right answer gives it back to you. It may sometimes need a little help, a little push from the engine, maybe from a DBA, figuring out what's wrong. But it still can be done. And it may just take longer than you expect until someone tunes some things, but your code works basically the same and probably even better. So keep building, keep writing software. All right, so this is gonna be my last one of these until the new year. Gonna break for the holidays, eat too much food, play too many games, watch too many movies. Got a lot of stuff going on like that. When I get back, I've written some of these. I'm gonna probably write some when I'm not watching these movies. We're gonna talk a little bit about what makes a table, and relational form, first normal form, talking about uniqueness, all the properties of what makes things unique, performance, all this, more than normal forms, lots of things. Maybe even talk about nulls. But for now, I think you should, if you're so inclined, go enjoy your holidays, and let's meet back up after the Holidays are over. All right. Thank you.